So I think my E is behind. If we can see, no, I probably can't see it with the light, but anyway, I have an E somewhere. It's kind of it's behind by 10 to the x. But also you can just do e to the 1. That's actually usually what I do. The other thing I would say, using a calculator, the less you put in, the better. Like the more times you, I don't know about you, but I have an awful habit of pressing the wrong button, and so it's better for you to put, the less you press the buttons, the better. So like -2 by 3, that should not be going in the calculator. That's -6. This one can. So plus 3 by, the way I'm doing is e to the 1, plus 4 by 1 over e, which is the same as divided by e, which is divided by e to the 1. 2 decimal places minus 1.53. I use this squiggly line to indicate approximation. You could do equals minus 1.53 to 2 decimal places, but that's that. Okay. Now ready for the next question. Okay, some more ribbon I have to do. So the next question is about anti-differentiation. Now this used to be a lot bigger back in 2004, but anyway. So they're asking us to find the following antiderivative, 4x cubed minus 6x plus 10 dx. I use slightly different language. If there's limits, I call it an integral. And if there are no limits, it's just an antiderivative. We're looking for the things that you differentiate to get end up with that. Now you might possibly do this in your head. I mean, where could you get a 4x cubed by differentiating x to the 4? Where could you get a minus 6x by differentiating minus 3x squared? Where could you get a 10 from differentiating 10x? And then you're very close, but there could also be a constant, say like plus 3. So you include that, but it could be any constant, so you call it plus c. Now what I'll do is we'll use the tables. I don't know how much you do on these days, but for me this is not a difficult antiderivative. Again, you do term by term fixing constants. So fix the 4, antiderivative x cubed is x to the 4 over 4. Fix the 6, and then x is x to the 1. If you want to put it in that framework, so its antiderivative is x squared over 2. I would do the 10 in your head. What is the what you have to differentiate to end up with 10x. And then, as I mentioned, we've got this plus c. We could tidy this thing up. Maybe we should. So I'll put in the c in the next line. So 4 divided by 4 is 1. 6 divided by 2 is 3. Plus 10x. Plus c. Have I answered the question as asked? Did I find this? Yes, I did. This means find all the things. Find all the things that differentiate with respect to x. Give you this. Okay, that's part A. Now let's look at part B. Part of the graph of a cubic function f of x is shown below. The graph cuts the x-axis at 3 points A, B, and C. Okay. I'll do a little sketch of it. This is part B. Very, very rough sketch. Now you should be familiar with the shape of the cubic. An x cubed should be equal to 0 in general 3 times, so that's where you're getting these 3 things. So this one is 2, 0, that's point A, point B, and point C. Now you're supposed to have the exam paper in front of you, so if that's drawn too small, I'm not too bothered. So I'm saying, given that the derivative of this function is this, find the function. Okay. So you can use some antiderivative notation here, but I don't think it's completely necessary. So they're telling us that the derivative of this thing is 6x squared minus 54x plus 109. And I think we can just antidifferentiate straight away. So without the symbols, I don't think you need them. So we'll just antidifferentiate away. So antidifferentiate the derivative, you get the original function. It's a sum, so we'll do term by term, fixing constants. So fix the 6, antiderivative of x squared is x cubed over 3. Fix the minus 54, similar to above, x is x to the 1. And So the antiderivative of x at 1 is x squared over 2. Antiderivative of 109 is 109x. And then what we have is, okay, there could be some constant here as well. So then it says, oh, find out this. Now, have we got the answers in front of us, which makes this, in my opinion, not a difficult question, but have we got 2x cubed? We have. Have we got the minus 54 over 2 equal to minus 27? We have. Have we got the 109? We have. We have to show that the c is minus 126. So basically the story is that there's loads of functions that have this derivative. Take this curve, shift it up and down. If you know that the derivative is the slope, shifting this up and down doesn't affect the slope. I mean, the slope at this peak is 0, whether it's here or up here. So adding or subtracting constant doesn't affect the slope, but only one of those functions will, for example, at x equal to 2 have a y equal to 0. So there's loads of things, like this is loads of functions, this is loads of functions, but if you give it one piece more information, it'll narrow it down from the family of functions. So what we're looking at is that we know that f of 2 is equal to 0. So if we evaluate f of 2, we get 6 over 3 is 2 by 2 cubed. Minus 54 over 2 is minus 27 by 2 squared. Plus 109 by 2 plus c, we know that this has to equal 0. So I can solve this pretty quickly by, just in my head, this is a single number. Take away from both sides, so c is equal to 0 minus, again, put as little into the calculator as possible, and the more that you do mental maths, the better, for many, many different reasons. So this, don't put in 2 by 2 cubed, come on, that's 16. This one maybe you might want to do 27 by 4, that's probably fair enough, 108, and then take away 109 by 2 is 218. The less times you press this thing, the better. I get c is equal to minus 126. And as far as I'm concerned, we're finished. Okay. Find the coordinates of the points B and C. So we have the function. It's all this stuff with the c equal to minus 126. And it's asking us to find the coordinates of B and C. Now this is an algebra problem. And a deep algebra problem, because what it's about is we're essentially solving f of x, which is 2x cubed minus 27x squared plus 109x minus 126 equal to 0. Okay. And we're trying to, okay, now this, as we said, x cubed has 3 solutions, 1, 2, 3, and so we have one of them. And how do we solve these things? So basically what you want to do is you want to factorize this. I think that this is something that comes up a lot in the higher level Lean Start paper 1. You need to know something called the factor theorem. It says if you've got a root, so a root is a number that you put into this and you get out 0. And you need to know that the graph of a function is the form input, output. So 2 goes in, 0 goes out. That means that 2 is a root. And the factor theorem says, the side here, the factor theorem says if k is a root, a number you put in you get out 0, like 2, that means that, and it works both ways, which I'll explain in a second, x minus k a factor. What I mean by it works both ways is that if x minus k is a factor, then k is a root. That's kind of easier to show. This is called the factor theorem. So what that means is that x plus 2 is a factor of this. Now there's different ways we can go about this. Now usually you're trained through the polynomial long division. So normally what you do here is you do 2x cubed minus 27x squared plus 109x minus 126 divided by x minus 2. And you get and then so this thing will be equal to that by that. And so to say when this is equal to 0, it's say that by that is equal to 0. We know this gives x equal to 2. So you solve this quadratic equal to 0, to give you the other two roots. I'm contemplating doing this a different way, but I don't think it's particularly easier. So what you could do is you could say that 2x cubed minus 27x plus 109x minus 126 is equal to 2 by x minus 2 by x squared plus bx plus c. And you could generate equations in b and c. But maybe we may as well do it like this. It is a little bit mysterious. I would say that probably the attitude you should take to this is that it works. I haven't done this in about 5 years, so hopefully it doesn't go wrong. X by 2x cubed, no. What by 2x cubed gives you, what by x gives you 2x cubed would be 2x squared. So let's multiply out. 2x squared by x is 2x cubed. 2x squared by minus 2 gives me minus 4x squared. Now to take this away, I change the sign and add. This gives us 0, and here I've got 4x squared minus 27x squared is minus 23x squared. Take down this 109x. Now this is guaranteed to go in evenly. That's what the factor theorem says. So if it doesn't go in evenly, a mistake has been made, and you can find that mistake. So how many times does x by what gives me minus 23x squared minus 23x? So minus 23x by x gives me minus 23x squared. Minus 23x by minus 2 gives me plus 46x. Change the sign and add. 109x minus 46, well I see, am I getting 60, what am I getting? 54 and 9 is 63x. Bring down the minus 126, and this goes in exactly 63 times. There has to be a remainder of 0, or else you've made a mistake. The factor theorem guarantees that you get nothing. So this f of, what's this here called? F of x. So f of x is equal to, so just like say 3 divided by 27 is 9, so 3 by 9 is 27, f of x here is x minus 2 by this quadratic here. And as we've seen so many times, now if you want to solve some things multiplied together equal to 0, either that's 0 or that's 0. This gives you x equal to 2, we've already encountered this, so now we're interested in solving this equal to 0. You could run away to the minus b formula, it might even need it, but as I said, I recommend that you factorize when you can. So we'll try and factorize this yoke. Otherwise we just have to use the minus b formula, so be it. Not the end of the world. The other thing, of course, I can do is have a little look at the exam paper, and if it speaks about decimal places, it doesn't, but if it did, then maybe it would tell me I probably do need the formula. So the AC method says you do 2 by 63, and you get 126 there. Now, I think this is a lot of factors, so I might need 2 of these yokes. 126, so 1 by 1, you go 1, 2, 3. 2 by 63, 3 by 42. Now, I'm not going to stop, I'm going to keep on going even if the actual one comes up. 4 by, doesn't quite go, like 31 and a half or something. 5 doesn't go, 6 does go. 6 by, is it 21? No, that's terrible, yeah, 21, yeah. 7, does it go? Yeah, it does, because this is a multiple of 7. So it's 7 by 126, well, 140 is 20 of them, so it's 2 less, 18. That's going to be the one. 8, does 8 go? No, because 8 goes into 120 evenly, 6 remainder, no good. Does 9 go? It will, because there's 9 in this. That's what I think anyway. Let's see, 9 by, I don't recognize that, 14. 10 doesn't go, 11 doesn't go, 12 doesn't go, 13 doesn't go, doesn't, no, because 130 is 4 off. 14 we've already got. And the question is, can we make up minus 23 with this? No. 7 by 18, right? Can't make up minus 23. Oh, here it is. Sorry. So replace the minus 23x with minus 9x minus 14x. Most of us would have ran to we would have ran to the minus b by now, and it's alright, but if you want to listen to me and take my advice, when you, like, the time to go to the minus b formula is a bit of pressure in the exam, fair enough, you're having a bit of, you know, a bit of an issue, but doing any exercises, doing any study, I recommend factorizing when you can. And I don't have the time necessary to recommend why, but just trust me. What's common out of the first two? X. Give it 2x minus 9. And then take something out of the second two that leaves 2x minus 9 again. Minus 7 does the trick. There's various different reasons why this is a good way of factorizing. Maybe you should come up with what they are. Take out a common factor now, 2x minus 9. And now we've got two numbers multiplied together giving us 0. So either the first one is 0 or the second one is 0. Here what I'm going to do is I'm going to add 9 to both sides, and after that I'm going to divide by 2. So if I add 9 to both sides, I get 2x equal to 9, and then divide both sides by 2, I get x equal to 9 over 2. And then this one, well, this one's a bit easier, I just have to add 7 to both sides. Now, have I answered the question that's asked? Find the coordinates of the point B and C. Now you've got the picture of B and C. They have y coordinates of 0. So now, let's not mess it up from here. B, if you had the picture on the previous page, was the first one with the smaller value of x. This is 4.5, so this is the B one. And the y coordinate is 0. And C is 7, 0. You can check your answer here by substituting in 7 and 9 over 2 into this, or even into this. And it's important that it makes sense that B, the first one, has a smaller number here. But there we go, that's it. Okay. Question 5. Right. So it says 3 plus 2i is a root of z squared plus pz plus q equals 0. I'd have a little bit of griping with them. It's a solution of it. The root is of z squared plus pz plus q. Where p, q are real numbers and I squared is minus 1. Find the value of p and the value of q. Okay, so I'm going to write down, not like they do it, I don't really like what they do. So they've got a function f of z equal to z squared plus pz plus q. So p and q are real numbers, and we know that 3 plus 2i is a root of this. Now there's actually so I will just look at some approaches to this. So the easy thing to do is probably to substitute in this and get 0, because what you're going to get is, if you sub in 3 plus 2i into this, you are going to get, and maybe we'll do this, maybe we'll actually do this question a few different ways. So we'll do this way first. There's some cleverer ways of doing this. There's a very clever way of doing this, but we'll just do, this is probably the basic way of doing it. So we get 3 plus 2i squared plus p times 3 plus 2i plus q is equal to 0. And what we're going to get on the left hand side here is a complex number equals 0. So the real part will have to be 0, the imaginary part will have to be 0, and furthermore p and q, so you get two equations in p and q, two equations, two unknown you can solve. If you're careful here, you get 3 by 3 is 9, 3 by 2i is 6i, 2i by 3 is also 6i, so you get 12i, and 2i by 2i is 4i squared is minus 4, plus p by 3 is 3p, p by 2i is 2pi, plus q, which is a real number, is equal to 0. Put the reals with the reals, imaginaries with the imaginaries. So I see 9 minus 4 is 5, plus 3p plus q. And then the imaginary part, I get 12 plus 2p. Oh, maybe this is actually easier than the way I was going to do it. I thought you'd get two equations and two unknowns, but this equation is particularly straightforward. Now, just see if we haven't ever made a stupid mistake there. 9 minus 4 is 5, 3p and q, that's the real part, the imaginary, 12i plus 2pi, yeah, okay. So the 0 here is actually, no, it's not included, is actually 0 plus 0i. So the real, this part is 0, and the real part is 0, and also the imaginary part is 0. One of those equations being easier than the other. So we can say that 12 plus 2p must equal 0. And we'll just apply two quick functions there. I want to get rid of the 12, so I take away both, 12 from both sides, and then I want to get rid of the multiplied by 2. I'm going to divide both sides by 2. So I end up with 2p equals minus 12. Possibly, there's no real reason to go as fast as this. I'm just trying to say this is something that I'm sure you've no problem with. And now, because you know that p, this equation is fairly handy. So you have 5 plus 3, p is minus 6, plus q, that must also equal 0. So this looks like 5 minus 18, minus 13.